Okay, so we're going to work on how to find inverse functions. First of all, inverse functions only exist when a function is one-to-one to begin with. And you can check that by graphing the function you're looking at and seeing if it would pass the horizontal line test. But once you know it's a one-to-one function, then you change all the x's to y's and all the y's to x's. And then step 2 is to resolve that equation for y. I have called upon the students in class today to help me provide opportunities for you to see that at work, and I thank them for their willingness to participate in these upcoming examples. Enjoy.
In order to find inverses, you have to switch the y and the x. So you make this x equals y plus 7, and then you solve for y, so you minus 7 over, so it's x minus 7 y, or you can just rewrite that real quick. And you have your inverse.
To find the inverse, you switch x and y. Like that. Then resolve for y. And then that's the inverse of y equals 3x minus 4. Sometimes a function can be its own inverse. I'm going to show you how that happens here. So you switch x and y. 1 over y. And you times by y to get rid of the fraction. So then you have xy, yx equals 1. And then you will divide by x to get y by itself. And the inverse equals what you began with.
Okay, so the first step is you switch the x's and the y's. So you end up with x equals 2y plus 4 on top of y minus 3. So now you multiply both sides by y minus 3. So those cancel. And then you multiply this side by y minus 3. And then you have to distribute the x to this term. So now you have xy minus 3x equals 2y plus 4. So now you want to get the y's on the same side, so you switch the 2y and the negative 3x. So you get xy minus 2y equals 3x plus 4. Then you can take a y out, so you have x minus 2 equals 3x plus 4. And now you divide by x minus 2. So then you finish with 3x plus 4 over x minus 2.
So essentially what you want to do, it's pretty easy, is first you have your first function right here, and then whatever you believe the inverse of it is, you put it into y2, and then if you really want to, you can put that little x right there in the y3, bold the line, and then you would just hit graph. And then you would just get a thing like that, which obviously it's still graphing. Now it would be an inverse because it mirrors on each side of the thing, and yeah, that's pretty much all.
Alright, here we go. To prove that these two functions are inverses algebraically, we've got to take g of x into f of x, and then f of x into g of x, and we should get x to be the final answer for both of them. So we'll start by putting g of x into f of x by taking 3, and then x plus 2 over 3. Subtract 2. Put 3 is actually just 3 over 1, and you can cancel those 3's. And so then you've got x plus 2 minus 2, which is just x. So the first one works. Then you go to the second one, and you put 3x minus 2 there, add 2, put it all over 3. Well, those parentheses aren't doing us any good, so we can get rid of them pretty much. And then we've got 3x minus 2 plus 2, which is the same as just 3x because the 2's cancel out, which is 3x over 3, which is just the same as x. They both equal x, so these are inverses.